Good morning, everyone. As Kajal said, NumPy numerical Python. In this section, we are going to cover the following topics: installing and importing NumPy, creating arrays, array attributes and special functions, accessing array elements, mathematical operations or arithmetic operations, modifying operations, and statistical function. Installing and importing NumPy. Before using NumPy, we need to install it in Python. The syntax is here: pip install NumPy. After installation, once NumPy is installed successfully, we can import it into our Python program. Importing means adding the NumPy library so that we can use its function and features in our program. Here is the syntax: import NumPy as NP. Here we have used alias for NumPy for short name NP. Creating array. An array is a collection of elements stored in a single variable. NumPy array are similar to Python lists, but they are faster, more efficient, easier for mathematical operations. Arrays are the main feature of NumPy. Creating an array. In NumPy, arrays are created using array function. Here's the syntax: numpy.array. Now 1D and 2D array. Here is the difference between 1D array and 2D array. 1D array contains elements in a single row, while 2D array contains rows and columns. 1D array uses one pair of square brackets, while 2D array uses multiple square brackets. 1D array similar to a simple list, and 2D array similar to a table or a matrix. And in 1D array, it has only one dimension, and in 2D, it has two dimensions. Here is an example, the output of this program. Now, array attributes and special functions. Here are array attributes: endine, shape, size, dtype, and special functions: np0s, np1s, nparrange, np linspace, npi. So let's see it one by one. Array attributes. Array attributes provide information about the structure and properties of an array. Endime returns the number of dimensions of the array. Shape returns the shape of the array, rows and columns. Size returns the total number of elements in the array. Dtype returns the data type of the elements in the array. So here's the example of a program. We have taken array and print its endime. The output shows 2 because it is in 2 dimension. Then the shape is what? Rows and columns. So first it has written the row, that is 2, and then column, that is 3. After that, the size is just the multiplication of rows and columns, and its d type is int 64. After that, special functions. What are the special functions? np.zeros, np.ones, np.arrange, np.linspace, and np.I. So let's cover it one by one. Here in the program, first we have done np.zeros. That is, it will print an array full of 0. Now you can notice that 0, after that there is a dot. That means in Python, the Python takes float default float. After that, np.ones. In this, it will take an array filled with ones. Here you can see that. After that, nparrange creates an array with values in a specified range. So see, it has taken 1, comma 10. So it has taken 1 to 9. It will not contain 10. After that, np.linspace creates evenly spaced values between two numbers. So here is the start, stop, and the value, which is how many numbers will be there, and they have a the spaced value will be same. So here as you can see, 1, 3.25, 5.5, 7.75, and then 10. So each number has a 2.25 gap. And the last, np.I creates an identity matrix. Here we have taken 3. So what it will do, it will take 3 rows and 3 columns and diagonally fill 1. So if we would have filled 6, it would have taken 6 rows and 6 columns and diagonally fill 1. Next, accessing array elements. Accessing array elements means retrieving or selecting data from an array. In NumPy, array elements can be accessed using index and slicing. Here's the difference. Index used to access a single element while slicing used to access multiple elements. Index returns one value and slicing returns a portion of the array. Index uses a single index number and slicing uses start, stop, and step value. In indexing, we will see two types, positive indexing and negative indexing. So in positive indexing, you can see we will start positive indexing from here 0, 1, 2, 3, 4. So print array 0 means the first one, that is 10. So 10 will be print out. Similarly 2, so 0, 1, 2. 2 in the index 2, it is 30. So 30 will be print out. This is the positive indexing. In negative indexing, we will take negative. From the last, we will start from minus 1. Minus 1, minus 2, minus 3, minus 4, and minus 5. Print array minus 5, minus 1. That is, minus 1 is 50. So it will print 50. Print array minus 3. So minus 1, minus 2, and minus 3. That is 30. So it printed 30. Slicing. So we can do slicing in three ways. That is first start and stop only, and start stop step, and negative slicing. In start stop, the first value is 1 and then the stop value is 5. So start it will do from here because it is the first one is 0 and then 1. So 20, 1, 2, 3, 4. So it will print till 4 because there is 5. So 20, 30, 40, and 50. In start stop step value, here in last it add a step value. So it will print 10, 30, 50. It has a step of two values like 10. After that it will not print 20, then 30 not print 40, then 50, and not 60. After that negative slicing is similar. The last number is minus 1, and after that it will, you can see, minus 2, minus 3, minus 4, minus 5. It will go on. So the number is minus 5. This is the minus 5. So 20, 30, 40, and 50. Then mathematical operations. NumPy allows mathematical operations to be performed directly on arrays. These operations are fast, simple, and efficient. In NumPy, operations are performed element-wise. This means the operation is applied to corresponding elements of the arrays. Types of array operations. addition, subtraction, multiplication, division, and power operation. Here is an example. Addition adds corresponding elements of arrays. Sub- Subtraction subtracts corresponding elements of array. Multiplication multiplies corresponding elements of arrays. Division divides corresponding elements of arrays. And power operation raises array elements to a specified power. Here we have taken two separate array. So in first we are adding. So A plus B, the output will be the addition of the number. That is 10 plus 1, it's 11, 20 plus 2, it's 22, and 30 plus 3, it's 33. So here we are adding the number, and subtraction A minus B. It is similarly, it is subtracting the values of B from A. So you can see 10 minus 1 is 9, and so on. Multiplication, it is multiplying the array of A and then array of B, that is 10, 40, 90. In division, it is dividing the numbers, and in power operation, it is doing the square because we have taken here 2. So star double star means it will raise a power to that array. Modifying operations. NumPy provides various operations to modify the structure and arrangement of arrays easily. Topics we will cover here are concatenation, that means combines two or more arrays. Reshaping changes the shape of an array without changing data. Splitting divides an array into multiple smaller arrays. Here is the example of each operations. Concatenation, we have taken two array and did the operation np.concatenate. This is the syntax. Inside it, we have filled the argument a comma b and printed it. So you can see after this array one a array 1 2 3, it has joined the next array b, that is 4 5 6. So it has made one single array. Reshaping, in reshaping it has taken first one array, and in B, it has reshaped it by giving 2 comma 3. So what it will do, it will take 2 rows and 3 columns. See, there are 6 numbers. So 1, 2, 3, and then 4, 5, 6. Splitting. In splitting, it has first taken one, 1D array and then split it. So A comma 3. A means it has taken this array, and 3 it means it has divided into 3 array. This is the first one, second one, and this is the third one. Statistical function. Statistical function are used to analyze and interpret numerical data easily. NumPy provides built-in statistical functions that help in performing calculations quickly and efficiently. These functions are useful for finding average values, identifying maximum and minimum value, calculating totals, understanding data patterns. Statistical functions are widely used in data science, artificial intelligence, research, business analysts, and scientific calculations. So here are the statistical functions: np.min, np.max, np.sum, np.mean, and np.median. So what they will do, first np.min finds the minimum value in the array. Here's the array. It will find the minimum value. What is the minimum value? 10. So it will print out 10. Similarly, in max function, it will find out the maximum value, that is 50, and print it out. In sum, it will add all the values inside the array, that is 10 plus 20 plus 30 plus 40 and 50, that makes 150. Now np.mean What this will do, finds the average value of array element. It will find the average, and you can see it has taken in float, and in median it has also taken in float. What does median do? Finds the middle value of the array. Now at last you are wondering, where is NumPy used in real life? How NumPy is used in different fields, and what are its practical applications? So these are student marks analysis used in daily temperature analysis, shop sales analysis, cricket scores analysis, and school attendance analysis. About this, Aksa will tell you clearly. Till then, thank you.
Good morning, everyone. Today I am going to explain the real life examples of NumPy. As you can see, the first example is student marks analysis using NumPy. Here I have created a 2D array called as marks. Here each row represents the particular student and each column represents a particular subject. Firstly, we are going to find the highest marks. The highest marks is being in find using the max function. If we will write print marks dot max, it is going to print the highest marks, which is 84. Nextly, we are going to use the mean function to calculate the mean of all the students. If you will write here, as you can see, the average marks is 66.25. Nextly we are going to find the subject wise average. Subject wise average means we are going to take a particular particular column. If we can assume that the first column is for science, second is for English, and third is for maths, then we are going to firstly we are going to find the average of the all of the marks of a particular subject. If we will write print marks dot mean x is equals to 0, it will print the average of the marks, like here 76.25, 68.25, and 54.25. Nextly, we are going to find the total of student-wise total. It will ask sum all the marks of a particular student and print it. As you can see, it is 201 for the first student, 198 for the second student, 203 for the third student, and 193 for the fourth student. Nextly, we are going to access specific values using index position. As I have already told you that indexing in NumPy starts from 0 if the first is for row and the second 2 is for column. If we will firstly write 0, it is representing the first row and 2 means the column, then it will print 56. This helps us in understanding or analyzing the students marks. Next I have collected the data of daily temperature for analyzing the temperature distribution. Firstly, you can see I have created a 2D array called as temps. Here, a particular row represents a day and a particular column represents the first column is for morning, second is for afternoon, and third is for evening. If we want to see the highest temperature, we will write print temps dot max. It will show the highest temperature. As you can see, the highest temperature is 35. Nextly, we are going to find the average of temperature, which is we will find by writing print temps dot mean. It will print the average temperature, that is 31.0. Nextly, we are going to print the time-wise average. We will write print temps dot mean x is equals to 0. X is equals to 0 means we are going to find it row wise, not in column wise, and it will print 30.5, 31.5, and 31.0. This helps us in analyzing the weather pattern easily. Thirdly, I have collected a shop sale data. Here, each row represents the sale of a particular day, and each column represents the sale of a particular product. If we want to see the highest sale, we are going to use max function. If we will write print sale dot max, it is going to print the highest value, that is 500. If we want to see the average sales, I will write print sales dot mean. It will show the average sale, which is 306.66. If we want to find the day wise total, we are going to write print sale dot sum. It will add x is equals to 0. X is equals to 0 means row wise. With the help of this, we can see the total sales of a particular day. It will sum all the data of a first row and all those rows, like it will plus 200 plus 300 plus 250, and it will print the day wise like 750, 100, 1005, 1050, 530, 1350. This helps us in analyzing the shop sales. Next, it will if we want to access the particular element, or if we want to print the day one and product C, if we will conclude this as day one and this is product C, then it will print 250. As you can see here, it is printing 250. Nextly, we are going. I have collected the data of scores of the cricket. Here, the scores is considered as a 2D array named score, in which the row represents the player, and each column represent match of score. First, I have printed all the scores. Then using max function, I found the highest score. As you can see, the highest score is 90. Then I have used mean function to find the average score, and the mean of the mean score is 57.5. Then I have found the player wise total, which means that our score of a particular player by using x is equals to 1, and as you can see, it prints 135, 205, 115, and 235. If we want to access players one match 3 score, we will write score in square bracket 0 comma 2. It will print the score of player one of match 3. As you can see, it's 30. This will help us in analyzing the cricket marks of a particular player or the matches. Here, in the fifth example, I am collected the data of school attendance analysis. Here, as you can see, I have created a 2D array called as attendance. Attendance. First I have printed the attendance table. Then here I 1 means present and 0 means absent. Then I have used some function to found the total attendance. As you can see, the attendance of first is 9. Total attendance is 9. Then I have used mean function to give average attendance. And as you can see, the average attendance is 0.75. Then I have used some function x is equals to 0 to calculate the attendance of per day. And as you can see, it's 333. Then finally I have accessed the attendance of student 1 on day 3, which is 0 means absent. Then it is printing 0 means that a student is absent on the third day. Thank you.